Bismillahirrahmanirrahim. How are you, students? Today we will start unit number 2, subject physics. Name of this chapter is kinematics. Kinematics is the branch of physics and a subdivision of classical mechanics concerned with the geometrical possible motion of a body or system of bodies without consideration of the forces involved, causes and effect of the motion. Basically, kinematics is that branch of physics in which we study motion of the bodies without reference to force. You study motion. You study motion without reference to force. Without reference to force. Without reference to force. So study of motion without reference to force is called kinematics. So you should study speed, velocity, time, but you should not consider force. Now, after this, we will go into detail of state. State is what? The condition of a person or thing is with respect to circumstances or attributes. A situation in which a body is likely to be found. For example, if you look at your surrounding, you will see different objects. Might be someone is changing its surrounding, and somebody will not change or does not change its surrounding. So according to that, you decide the state. So a situation in which a body is likely to be found is called state. So here are two states, rest and motion. Might be a chair lying in the classroom, a book lying on a table. These are the example of state of rest. Rest. An object is said to be at rest if it does not change its position with respect to its surrounding or with time. So if a body is not changing its position, the body is said to be in state of rest. For example, in this figure, it is in state of rest. It is also in state of rest. And this one is also in state of rest because it does not change its position with respect to the surrounding as shown. The observation is that these three objects does not change its position, so will be supposed to be in state of rest. Now, motion. An object is said to be in motion if the position changes with respect to its surrounding. So if a body is changing its position with respect to its surrounding, the body is said to be in state of motion. State of motion. For example, this player is running or athlete is running. It will be in state of motion. This one is cycling, is doing cycling. So it will be also in state of motion because the observation about these two bodies or objects is that it changing its position with respect to its surrounding. So if you change your position, you will be supposed to be in state of motion. If you does not change your position, you will be supposed to be in state of rest. Difference between rest and motion. Rest is a body said to be at rest if its position does not change with respect to a fixed point in its surrounding. This is another definition for you people. Example, a book lying on the table, a bench fixed in a park. Motion, a body is said to be in motion if its position continuously changes with respect to its surrounding. For example, flying birds, a boy playing football. So changing its position, motion. If it does not change its position, rest. The state of rest and motion of the bodies is relative to each other. A body can be both at rest and in motion at the same time. How it is possible that one body will be in two different states? If you are driving a car, a person sitting in the same car will have same velocity, will have same speed is your the speed of both the bodies is same. So you will be in state of rest with respect to the person sitting in the same car, but you are in state of motion with respect to an observer outside the car. So it the position to decide whether the state of the body is rest or motion is relative. It depends on the observation and on the position of the observer. So state is relative. So same body will be at different state for different observer. Types of motion. If we observe carefully, we will find that everything in the universe in motion. However, different objects move differently. Some objects move along a straight line, some move in a curved path, and some move in some other way. According to this, we can say that there are three types of motion, which are given is translatory, rotatory, vibratory motion. Different objects have different types of motion. Might be in straight line, might be in curved path, might be to and fro motion, circular motion, in zigzag path. Any possibility, any type of motion is possible. So types of motion is divided into three categories. In three, there are three types of motion: translatory, rotatory, and vibratory. So comes towards the first type, translatory motion. In a translatory motion, a body moves along a line without any rotation. The line may be straight or curved. I will give you a simple definition of this translatory motion. Simple idea. Simple idea is you have an object. It is composed of different atoms. The motion of this body is straight one. This is the motion of the object. If the particle have same motion, if object's motion is straight and the particle atom molecules are larger particle, whatever of which it is composed, if the particle have exactly the same motion, then the motion will be translatory. If the body have circular motion, the particle have also circular motion. If the body have straight motion, the particle have straight motion. If it is in zigzag path, the particle motion is also zigzag path. So when the motion of the object is synchronized with the motion of the particles of which it is composed, is called translatory motion. Watch various objects are moving. Do they move along a straight line? Do they move along a circle? A car moving in straight line has translatory motion. Similarly, an aeroplane moving straight is in translational motion. So we will go into detail of translatory motion. Types of translatory motion. It's translatory. This word is translatory. Types of translatory motion. Translatory motion is further divided into three types: linear motion, circular motion, random motion. Linear motion, circular motion, random motion. Linear motion. The motion of a body in a straight line. Straight line. The motion of a body in a straight line. Motion of a body in a straight line. So if the object have motion in straight line and the particle have also motion in straight line, then the motion will be linear. The motion will be linear. If the object is moving in circular path, if the object is moving in circular path, for example, circular path, object motion is circular, and the particle motion is also circular. It is also translatory motion. If a body is moving in random path, the particle motion is also random, path is random, then such type of motion is called random motion. So the motion of the body is synchronized with the motion of the particles of which it is composed. Then such type of motion is called translatory motion. Whether it is linear, means straight line, circular, or random, whatever the type of motion is. Now, next example of translatory motion: motion of a train, motion of earth, motion of aeroplane, motion of a gas molecule. All these are the example of translatory motion. But even a single example might be translatory, might be vibratory, might be rotatory. It depends on the condition and on the situation. So when you are studying, you look to the type of motion and the situation and to the condition. If to which type, if it matches with linear translatory motion, it will be considered translatory. If it matches the rotatory motion, it will be considered rotatory. Or then if it matches with vibratory, then it will be considered vibratory. So you should look to the type of motion and you should look to the condition and the situation. Linear motion. In this case, ball is thrown. So the straight line motion of a body is known as its linear motion. Straight line motion of a body is known as its linear motion. We come across many objects which are moving in a straight line. The motion of objects such as car moving on a straight and level road is linear motion. Aeroplane flying straight in air and objects falling vertically downward are also the example of linear motion. For example, this arrow represents the motion of object. This particle motion is like this, also a straight one. So the particle motion is synchronized with the motion of the object. So it is a linear motion. So if the motion of the object is in straight path and the particle motion is also in straight path, it will be translatory, and in translatory it will be linear motion. Next example in daily life of linear motion is The motion of the car on the road, sliding a boy in a straight line is the example of a linear motion. For example, this apple, an apple falling from a tree, is an example of a linear motion. Cause straight line motion, particle motion, and the object motion and the particle motion is exactly the same. This is also uh, linear motion. March past by student on straight path is also an example of a linear motion. Circular motion. The motion of an object in a circular path is known as circular motion. For example, the rotation of moon around the earth. Rotation of moon around the earth is known as circular motion. It is type of translatory motion because the motion of moon is circular and exactly the particle have exactly the same type of motion. So it's an example of circular motion. A toy train on circular track. Earth revolving around the sun is an example of circular motion. A bicycle or a car moving along a circular track possesses circular motion. The motion of the moon around the earth is also an example of circular motion. Example of circular motion in daily life. First one, example, you can see the diagram. This is circular motion. This is also circular motion. Circular motion. Circular motion. Circular motion. And circular motion. It is at particular duration. The decision will be at particular duration of time. Might be the car moving on this road will be circular, but here it will be linear. So depends on the condition. The motion of the electron around the nucleus. The motion of toy car on the circular track. The motion of planet around the sun. These are the examples. Random motion. The disorder or irregular motion of a body is called random motion. The motion of a body in a zigzag path is called random motion. The motion of butterfly is called random motion. The motion of a body in unpredicted path is called random motion. Have you noticed the type of motion of insect in birds? The movement are irregular and disordered, unpredicted. The motion of insect in birds is random motion. The motion of dust or smoke particles in the air is also random motion. The Brownian motion of a gas or liquid molecules along a zigzag path is also example of random motion. The random motion of a gas molecule is called Brownian motion. Rotatory motion. The spinning motion of a body about its axis is called its rotatory motion. In rotatory motion, uh, body rotate about a line which is which is which is in the body, and in circular motion the rotation is around a point which is outside the body. Study of motion of a tape, it is spinning around an axis. Particles of the spinning top move in a circle and thus individual particle possesses circular motion. Thus the top possesses circular motion. The top spin about its axis, passing through it, and thus it possesses rotatory motion. An axis is a line around which a body rotates. The line about which the body rotates is called axis. In a circular motion, the point about which a body goes around is outside the body. In rotatory motion, the line around which a body moves about is passing through the body itself. Circular motion is around a point outside the body. And rotatory motion is around a line which is inside the body. Rotatory motion, example of rotatory motion. The motion of the earth about its geometric axis that causes day and night is rotatory motion. The motion of the wheel about its axis in that of steering wheel are example of rotatory motion. So spinning top, the other example are also mentioned. You can see in the diagram rotatory motion is the motion around an axis. The motion of wheel. Now the last type of motion, vibratory motion. Motion of a body about its mean position is known as vibratory motion, or the to and fro motion of a body is called vibratory motion. Vibratory example of vibratory motion is shown in the diagram. The motion of a simple pendulum, uh, the motion of the baby repeat from one extreme to the other extreme with the swing. The motion of the pendulum of a clock about its mean position is also an example of vibratory motion. So any type of motion which keep on repeating itself about its mean position is called vibratory motion. The motion of the wire of a guitar when it is plugged, it rotate about its mean, vibrate about its mean position. So it is an example of vibratory motion. Now, children playing in a seesaw is an example of vibratory motion. Beside these examples, a baby in a cradle moving to and fro motion of the hammer of of a ringing electric bell, and the motion of the string of a sitar are some of the example of vibratory motion. Simple harmonic motion is also an example of vibratory motion. Periodic motion is also called vibratory motion. Thank you, students. Yeah. In next lecture, we will repeat these lesson. We will repeat this topic, and then we will start the next topic. So, thank you, student. Wish you best of luck.